In this video, we're going to look at hypothesis testing for two means that come from independent samples. The assumptions: random sampling was used, the samples are independent, and both populations are normal without outliers, or both of our sample sizes are greater than or equal to 30. So unlike with paired data, we are just going to make statements for our null and alternative hypotheses that compare our two population means. So we see that our null hypothesis is that the means are equal, mu1 equals mu2, and our alternative is either that they're not equal, mu1 is less than mu2, or mu1 is greater than mu2. So we did set up our alternative hypotheses this way for that paired data, but then we rewrote it so that we looked at the difference between those means, not the comparison of the two means. Step 2, find alpha. Step 3, we calculate our test statistic. Our test statistic formula: x bar 1 minus x bar 2 divided by the variance of sample 1 divided by n1 plus the variance of sample 2 divided by n2. I chose to say variance because the standard deviation squared is our variance. Now for the degrees of freedom, we're going to use whichever is smaller, n1 minus 1 or n2 minus 1. Step 4, make our decision for the critical value method. Again, this is a t-test since we're dealing with means. For critical value, you'll use t dot inverse. For the p-value method, we'll use t dot dist. And then step 5, we state our conclusion. A researcher hypothesizes that the average number of sports that colleges offer for males is greater than the average number of sports that colleges offer for females. From a sample of 50 colleges, the mean number of sports offered for males is 8.6 with a standard deviation of 3.3. And the mean number of sports offered for females is 7.9 with a standard deviation of 3.3. At alpha equals 0.01, is there enough evidence to support the claim? Now, with these problems, we know that we're setting up a hypothesis test because they're asking us if there's enough evidence to support our claim. And our claim here is that the number of sports offered for males is greater than that of females. But how do we know that we should treat this as independent data? A couple of indicators. One, we should be able to realize that those data sets are independent of one another, but also just in terms of thinking about the formulas that we need to use. In our previous set with the paired data, we needed to have the mean of differences and the standard deviation of differences. So either those values are provided or you're given raw data to find them. Since we're given two different means and two different standard deviations, and that's the only information given, that does give us another indication that this is independent samples. Our null hypothesis is always going to be that mu1 is equal to mu2. And then our alternative, let's start setting up our groups so that we can set up our inequality correctly. Since we're talking about males first, we'll call that group 1. And then we'll call females group 2. So the population mean for males will be mu1. The population mean for females will be mu2. The claim is that the number of sports offered for males is greater than the number of sports offered for females. So mu1 is greater than mu2. Step 2, alpha equals 0.01. Step 3, we calculate our test statistic. That formula is x bar 1 minus x bar 2, or t equals x bar 1 minus x bar 2 divided by s1 squared over n1 plus S2 squared over N2. So let's go to the right-hand side and start summarizing the information that's provided. X bar 1, or the mean for males, is 8.6. The standard deviation for males was 3.3. For females, the mean was 7.9. And the standard deviation was also 3.3. Now, we did sample 50 colleges and collected the number of sports for both. So our N is 50 for both. So substituting those values in, we get 8.6 minus 7.9 divided by the square root of 3.3 squared over 50 plus 3.3 squared over 50. Evaluating this, we only need parentheses in that numerator. And rounding to 2 decimal places, our test statistic is 1.06. Step 4, this is a right-tailed test. I'm going to use the p-value method for this example. Remember that the p-value method is based on our test statistic. Because this is a t-test, we're dealing with means, we're going to use t.dist. And to make our decision, we're going to compare our p-value and alpha. All right, so we've got our right tail. The area in the right tail represents our p-value. And we're trying to find the area there. We know that our right tail is bounded by our test statistic 1.06. Now our function t.dist is going to give the area to the left of this test statistic. So we're going to use the complement rule to calculate our p-value. So it's going to be 1 minus t.dist 1.06. And then our degrees of freedom, since our samples were the same size, it's going to be 50 minus 1, or 49, comma, true. Using Excel, that t-distribution function gives us an output of 0.8528, rounded to 4 decimal places. So when we subtract, our p-value is 0.1472. And then to make our decision, we want to compare this to alpha. Alpha is 0.01. So our p-value is greater than alpha. When our p-value is greater than alpha, our decision is failed to reject the null hypothesis. Now, similarly, if you chose to use the critical value method, or if that's your preference, or if you're asked to do both, depending on whatever the circumstances with your instructor, the critical value for this would have been 2.405. So if you wanted to go that other route, you could verify that answer there. Step 5 is our conclusion. Since our decision in step 4 was failed to reject the null hypothesis, then our conclusion is that there is not enough evidence to support the claim that the average number of sports that colleges offer for males is greater than the average number of sports that colleges offer for females. We wish to answer the question, do you think that the mean time for watching TV is different for a population of college men than it is for college women? So we have the following data. For the men, our sample size was 59. The sample mean was 2.37 and the standard deviation was 1.87. Our second group was women. Our sample size was 116. The sample mean time watching TV was 1.95 and the standard deviation was 1.51. So we are trying to verify a claim that the mean time is different for men and women. How do we know that these are independent samples? One, again, thinking about the nature of our two populations and our two samples, they should be independent of one another. But a very glaring and obvious clear identifier is that we have two different sample sizes. So we can't have matched pairs if we have different size samples. So our first step, we're going to state our null and alternative. The null hypothesis is that the means are equal. Mu1 equals mu2. And then the alternative, we're just determining if there's a difference. So mu1 is not equal to mu2. Step 2, alpha is 0.01. Step 3, we calculate our test statistic. That formula, T equals X bar 1 minus X bar 2 divided by the square root of S1 squared over N1 plus S2 squared over N2. We've got those values summarized at the very top here. X bar 1 is 2.37 minus 1.95. divided by the square root of 1.87 squared over 59 plus 1.51 squared over 116. Again, typing this all in at once, we need parentheses around the numerator, and rounding to 2 decimal places, we get T equals 1.49. Step 4, this is a two-tailed test. And since I used p-value on the last example, I'm going to use the critical value method here. Remember, critical value method based on alpha. Because this is a t-test, we're going to use t dot inverse. And to make our decision, we're going to compare our critical value and our test statistic. So we've set up a two-tailed test. The area in both tails represents our rejection region. So all of this in blue is a rejection region. Now we know the total area of our rejection region is alpha 0.01, which means that the area in each individual tail is 0.005. To find that negative critical value, we're going to use t dot inverse of 0.005 and then our degrees of freedom. Now the degrees of freedom, we now have to look at our two sample sizes, and we're going to use the smaller of our two sample sizes. So N1 was 59, which is smaller than N2 of 116. So we're going to use N1 and we're going to subtract 1 to find our degrees of freedom. So our degrees of freedom are going to be 58. So that output is negative 2.663, and that means our positive test statistic was positive 2.663. Now to make our decision, we want to place our test statistic 1.49 on this graph. 1.49 is less than 2.663, so it's going to be out here, outside of that shaded rejection region, which means our decision is failed to reject the null hypothesis. If you wanted to run this test using the p-value method as well, the p-value would end up being 0.1416. Step 5, we write our conclusion. Since our decision was failed to reject the null hypothesis, our conclusion is that there is not enough evidence to support the claim that the mean time of watching TV is different for college men and college women.